Tell me what you think of that one.
The right hilus is higher than the left and enlarged.
Okay. Well, let's look firstly at the lung. Any density change?
Yeah.
Yes.
Okay. What kind of a distribution?
Lobar, right upper
Okay.
lobe.
So we have unilateral localized water. Okay, so we have unilateral localized water. The considerations are cat feeding. The density is non-homogeneous, wouldn't you agree?
Yes.
Because the density up there doesn't look like this, doesn't look like this. This is homogeneous, homogeneous. This is non-homogeneous. But it's still localized. It's still in one place and it's localized. Okay, so did anything move?
Yes.
Yeah.
Yes. Hilus
Fisher.
Fisher.
is higher than the left one.
Mhm.
Never supposed to be higher than the left one. Fisher?
Yeah.
It looks like it. It's supposed to be down here. It's going like this. It didn't move very much, but it moved a little. That's why this isn't homogeneous. You know, if you only go from here to here, you still got lots of air in there, but not as much as normal. And so the ratio is shifting as you're shrinking it. The ratio is shifting. This is a great example of one of the direct signs. Remember? Fisher displacement, increased density. What's the third one? Third direct sign. Vascular crowding. Why do you get vascular crowding? Because the lung's getting smaller. But that's only visible very early. Why? What density are the blood vessels?
Water.
Okay, and so what happens to the lung as you shrink it? It becomes
More water density.
And what does it do? Silhouettes the blood vessels eventually. So you're going to shrink them, they're going to get closer and closer together, but what's in between them is increasing in density, and eventually you can't see them anymore. So vascular crowding is a very early sign. That's vascular crowding. Now, diaphragm's up, hilus is up, all going toward the increase in density. Maybe a slight decrease in the rib interspaces. They look a little smaller than over here. Displacement's hard to tell whether there's any tracheal displacement. We look on the lateral though, minor fissure. This is upper half of the major. This should be back here and this should be here. Going like this. They're going toward each other, aren't they? So we've got 1, 2, 3, 4, 5, 6 signs, all saying atelectasis. We got both direct and indirect signs. And is the hilus larger?
Yes.
And more dense? So what type of atelectasis is this?
Lobar.
It's resorption atelectasis, exactly. And where's the obstruction?
Right upper lobar.
It's in the right upper lobe bronchus. If it was in the main stem bronchus, the whole lung would collapse. It doesn't look like that when the whole lung collapses. This is going to be way up here, this is going to be way over here. The whole thing will be homogeneously opaque if the whole entire lung collapses. But you're going to get major shift going to, everything's going toward it. Diaphragm will be way up. The whole lung over here will overinflate and herniate across the midline if you collapse the whole entire lung. So it just depends on where the obstruction is. If the patient is an adult and they're over 40 and they look like this, they have a tumor until someone says no, they don't. The working diagnosis is endobronchial tumor because it's such a common cause of resorption atelectasis in adults. Now, it could end up they have asthma because asthma will do this in an adult just like it'll do it in a child. But if they're over 40, if they smoke and they're over 40, bingo, home run. They have lung cancer until proven otherwise because it's such a common cause of atelectasis. Perfect example.